Let us solve the exercise number 5 in the part B of data structure lab. In this exercise, we are supposed to write a program to convert a given infix expression into a postfix expression. Before we start writing the program, let us quickly recall how it can be done. So in order for us to convert a infix expression into a postfix expression, we are going to make use of a stack. And how do we achieve the same thing? So when I say that there is a stack, you are familiar that the stack, let us say, let me call that stack as yes, has a pointer called as top that indicates up to which point the stack is full. When you start the stack is generally empty, and this is indicated by a special condition, and that is top is equal to -1. Whenever we get this situation where top is equal to -1, we say that the stack is empty. And what we are doing, so when we try to convert an infix expression into the postfix expression, what we are doing is we are moving this open bracket and all these operators into stack. However, all these operands are there, 5, 4, 7, whatever it is. All these operands are moved directly to the output. So only the operators are moved into the stack. So let's start writing the program. I'm going to go to the code block here, and I'm going to click on the file, and I'm going to start a new file. Let me click on the C and C++ code, and let me go to the next. I'm going to start with the C program. So let's go ahead and let me select a folder wherein I'm supposed to save my file, and I'm going to say I to P. Let me say I to P. You can give any name, infix to postfix expression, and I'm going to click on save, and I'm going to finish it off. As usual, whenever we want to write a program, C program, generally we include a stdio.h. So this is required for me for my printf and the scanf statement. So I need that thing. And as I told you, we are going to make use of a stack for achieving our result. So let me start the stack. So I'm going to take the stack. And what is that we are putting into the stack? So we are putting these symbols, that is the plus symbol, the open bracket symbol, and the minus or star. All these are characters. You are familiar with that. So our stack will be a set of characters. So I'm going to call that as yes. And during the examination, you know very well, you may not go beyond 50 characters. So you may type 6 or 7 characters, but I'll take up to 50 characters. So your expression in what do I mean by saying that your expression cannot be more than 50 characters. So you cannot write a very lengthy expression. So write, and definitely you would write it during the examination. And the stack has one important pointer, and that indicates up to which point the stack is full, and it is generally represented as top. And I'm going to initialize it with -1, saying that the stack is empty. And you know very well, whenever we put an element into the stack, so whenever I want to put something into the stack, we say this operation as push operator. So this is the push. And whenever I want to pull out something, and we say that is pop. So we have two things that we are going to do it. So let us write the push operation. So I want to push a character. You know very well it is a set of characters. So let me call that as C. So I want to push a character, a general character C, into the stack. Generally, what you do is whenever before you push an element into the stack, you check whether the stack is full. So I'm not going to do it because I'm going to tell you that in this situation, the program that I'm going to write, a scenario wherein the stack is full will not be achieved. But in reality, whenever you are doing the stack, see to it that you check whether the stack is full or not. For this particular program, you don't require that condition. That's why I'm not putting it, because you are writing it for the examination. I don't want you to type extra things over here. So how do we push an element into the stack? We know that the stack is empty, and this is indicated by saying that the top is equal to -1. We first move the top by 1. How can I move the top by 1? So I'm going to say top is equal to top plus 1. So top plus 1, and you know that top is 0, top is -1. Currently top is -1, so this is the situation. Top is -1, and for that, if you add 1, 1 plus 1 is -1 plus 1 is going to make it as 0, so the top will move to this position, and you move one character into the stack. So let me say you are moving one character. Let this is just for example, so let me just say you're moving plus, just an example. I'm not considering this one. I'm not, don't connect that with this one. Just say that a plus is being moved. Now if I want to move one more element into the stack, what you do, first you increment the top, so top plus plus, so you increment the top. How do you increment the top? Plus plus top, so you increment the top first, so the top will move here. So 0 plus 1 is going to come here, and then whatever symbol you want, you push them. So how am I going to write that particular thing? I'm going to say that my stack is yes plus plus top. So increment the top by 1, and whatever character that is given to me, you just push it over here. So if the character is plus, you take that character plus and move it to the stack, and before you move it, increment the pointer by 1. Let us look at the second one, and that second one is, what if I want to move this one out of the stack? What if I want to pop this one out of the stack? So whenever you pop out, one of the element will come out. So in this case, the stack is a set of character, and what I'm going to get is a character. So what I pop up is going to be a character, and we are not going to give any parameter to this one. How do we move this one? So I'm going to return the top, whichever element which is there at the top, I'm going to return. So in this case, the top of the element is there at the position 0, that is the index 0, and what you have here is a plus. So this will be returned after pushing this, or after popping this out of the stack. You have to decrement the stack so that the stack becomes empty. So when you remove this element from the stack becomes empty. How do you achieve this one? You decrement the top by 1. So how do you write that? So top is equal to top minus 1. So generally you write like this: top is equal to top minus 1, or top minus minus. So this is what you do it. So you move one element, or pop one element from the stack and decrement the pointer by 1. So this is what I'm going to do it. So after moving this, you just decrement the pointer by 1 by writing top minus minus. However, there is a small problem with this one. And what is the problem? Suppose if you remove this element and now decrement the pointer by 1, so the stack is empty. Now if suppose somebody calls the method called as pop, what is it going to pop out? So that problem will come. So when the stack is empty, you are not supposed to pop out any element. So these are the two golden conditions. You know very well, before you push something into the stack, you check whether the stack is full. If the stack is full, you say it is overflow, and before you pop out any element of the stack, you check whether the stack is empty. If the stack is empty, you say it is underflow. So both the condition has to be checked. So I'm going to check for that condition here. So this you have to do it. There is no excuse for not checking this one, even though I have not checked here whether the stack is full or not, because in my scenario, that thing won't arrive. I'm going to explain why this, the top of what do I mean by saying that is I'm going to explain why that your overflow will not occur in that stack. Why you don't get that situation? Overflow won't come in this exercise, not in all the exercise, in this exercise. But definitely in this exercise, underflow story will appear. So when you pop the element, you will have a situation wherein the stack is empty. In that case, you may have to check for the underflow. So how do I check for the underflow? I'm going to say if top is equal to -1, then I am supposed to return something. So generally you write a statement in your stack program. You say stack is underflow and you exit the program, but I'm not going to exit the program. I'm going to just say that if the stack is empty, I'm going to return -1. Otherwise, I'm going to return whatever the element which is there at the top of the stack. Now, what is the significance of writing this one as -1? Why did I selected return -1? Why not return something? Okay, the reason is, this is a stack of characters. And how do you represent the character? You know that the characters are represented by ASCII. What are the values you get for the ASCII? ASCII starts from 0 and it will go up to 255. This is the extended ASCII. Okay, otherwise 128, whatever the one that you are familiar with. So the minimum ASCII value that you are going to get for any character is 0. 0 is nothing but your null character. So 255 may be something else, and you are familiar. The capital A has 65, small case A has 97. The ASCII values. You are familiar with these ASCII values for the characters. Now, our question is, why did I selected -1? Whenever I say a array of characters is returning -1. What is the meaning of saying -1? When you know that the ASCII starts from 0, -1 indicates that it is not a character. What is returned is not a character. So that's simple as that. So because the ASCII starts from 0 to 255, when I return -1, I'm indirectly saying that what you are getting is not a character. It is something else. Okay. So this is the reason why I've selected this one as -1. So let's go ahead with the other part of the program. So let us write the main. We have not completed everything, but let us start with the main. So I'm going to start with the void main. So void main, and some of you, I don't know, surprisingly you are writing this statement. Some of you, I don't know what is the problem with you. You write int main. If you are writing int main, you have to write one more line over here and return 0 or something. You have to write this return statement. So to avoid writing too many things during the examination, make it as void. When you say void, you are not returning anything, so that one line of writing extra is avoided. So let's start with the program, and what is given in our program is you are given a infix expression. That is what is given. You are given an infix expression. What is this infix expression? It is a string or set of characters. So let me write that one. So I'm going to say I have a character array called as an expression. I'm going to call it as expression, and I'm taking the size of it as 50. Now you notice that size of the expression is 50. That means to say that my expression size is 50. I will not take something beyond 50. And look at my stack. The stack is also 50. So the size of the expression and the size of the stack both are 50. That is the reason why you won't get a situation wherein your stack will be overflowing. It is not possible because I've taken both the size of the expression same as a size of the stack. Also, you will notice one strange thing. As I told you before, what is pushed into the stack is the open bracket, and all the operators are being pushed onto the stack. We don't push the operand into the stack. The operands are directly sent to the output. That means, in general, for every operator that you are pushing onto the stack, there are two operands that are moving out. So what is so strange about it? Suppose if you take this expression of size 50, if the size of this expression is 50, out of 50, if one of the element is pushed onto the stack, two elements will be sent to the output. They won't come to the stack at all. They are simply going out of the stack. So that means to say that this size, which I've taken it as 50, will not be achieved at all. So you won't have a situation wherein you will have this stack is overflowing. So that thing won't happen, because for every one symbol that is coming over here, two other symbols will go to the other side. You may say that, okay, but what will happen to the open bracket? When you have this open bracket, the close bracket is not pushed onto the stack. So that is one other situation. I'll talk about it slightly later. So you get 50% off over here. If one comes, the other won't come here. So that is the reason at no time this stack will be full. That is the reason I have not checked for one important condition. And what is that important condition? Whether the stack is full or not. So the overflow won't happen over here. Now what we are doing in this exercise, given an expression of characters, or given an expression, we take one character at a time. So you take one character, you take one character, you take one character, and so on. So at a time you take one character. Let me represent that with the variable c. So generally, so just to say that c will represent one character, so I'm going to write that c here. So one more variable that I'm going to take is c, that will represent one of the characters from this expression. One of the character is represented, any one is represented with the c. So this is general c. And you know very well, whenever we talk about this array, we are generally interested in the indices. So we just say I as an index. So when I is equal to 0, you get the first element. You know, you are familiar with the array. So first element of the array is index of the array is a of 0. Second is a of 1. Third is a of 2. So we start with I is equal to, generally we take I is equal to 0. So when I is equal to 0, you get the first element. Then I plus plus I becomes 1. Then you take the second element, I plus plus becomes I become 2. You take the third element. So you need, this is called as counter variable, and I'm going to take that counter variable right at the beginning. Done. Let me ask the question with the user. And what is the question that I'm going to ask with the user is enter a what is this infix, not postfix, the infix. This is the spelling. Okay, infix expression. Okay, hopefully that spelling is proper. Okay, infix expression, and I'm going to use a scanf statement. Let me go one line up. I'm going to use these accidentally pressed. Okay, scanf, and this is a string of characters. So I'm going to take yes, and I'm going to use the expression, that is the name of the array. So I don't have to use the ampersand sign. Don't make a mistake of putting ampersand sign, because it is the array name that is being used, and you know very well array name is a pointer. And then I'm going to use the control C and control V, and I'm going to say postfix expression. Postfix expression is, okay, say I'm putting one space here. Some of you are again not doing here, so there is one extra space. Otherwise the things will touch this one. So whenever you touch the type here, it will touch here. So then I'm supposed to uh, write the postfix expression. How am I going to do it? So I'm going to take one element at a time. So I'm going to take one element at a time, and I'm going to take the next element, and I'm going to take the next element, and so on and so forth, until I reach the end of the string. How do you say that the string has ended? You say that string has ended whenever you reach the null character. You know very well, when you encountered null in a string, that means it's the end of the string. End of the string is marked with a special character, and that is ASCII 0, which is the null character. So you take one element at a time, as long as the element that you take is not a null character. So as long as it is not null character, you take one element from the stack. So this is what I'm going to write. So you have an expression here. I'm going to write this statement. So while you take one element from the stack, so how do you take one element? You say expression, and let me initialize I is equal to 0. You know very well when you start, so I've initialized I equal to 0 here. So this is the one. So you know when you start as I told you before, I is equal to 0. You start with I is equal to 0. When I is equal to 0, you get this character. When I is equal to 1, you get this character, and so on. So I start with I equal to 0, and I'm going to say expression of I. That means when I is equal to 0. So when I is equal to 0, you are going to get this open bracket. So that is as simple as that. So as long as, and then you are going to increment the I. Next time you are going to say, when you start with the I is equal to 0, you get the open bracket. Then I plus plus, I becomes 1, you get 4. I plus plus, then you get next one, and so on, until you reach the null character. So as long as you are not reaching the null character, you are going to start taking one element at a time. So as long as you're not reached the null, so as long as you're not reached the null, you are going to take one element at a time, and you are going to do something with this. So how do I take one element? And I told you already, I told you, one of the element is represented with the variable c. So you are taking one variable c to represent one of the elements. So I'm going to say C is equal to expression of, you take one element of it, and you're going to do too many things here in between, and finally you're going to increment I by 1. So you know where. So you start I is equal to 0, you take one element, I plus plus, so I becomes 1, you take the second one, I plus plus, I becomes 2, and so on. So that I plus plus I have written here. So in between, you are supposed to do few things. What are the few things that you are supposed to do it? So first thing, what I have told you is, if it is the open bracket, or if it is this operators, you are going to push them into the stack. So you are supposed to push them into the stack. If it is a operand like this, in this case it is a constant, that is 4 and 5. So it is a number. So if it is a number, then you are going to send them directly to the output. So if it is a number, you directly send it to the output. Now this is in this particular expression, I have all of them are numbers, numerical values. But you know very well, you may also get a situation wherein instead of numbers, variables may be used. For example, here they have written a star b plus c to the power d, and so on. So instead of numbers, you may also have the symbols, that is the variable could be a, variable could be x, y, z, anything. All of them are alphabets. So you may have, variables are represented by the alphabets, or I, j, k, whatever it is. Whenever you get, so you may have 5 plus 4, or you may have an expression a plus b, where a is an operand and b is an operand and plus is the operator. So either a numerical value, or you may have a alphabet or alpha alphabet value. So in both the cases, whether it is a numerical value or alphabet value, you have to send them to the output. So let us write that story here. So how am I going to check that a given character c? So c is a general one, given this variable c. Given a character c, how do I check whether it is a alphabet or a number? For this, you know very well, you studied in your C program. We are going to make use of a built-in standard function, and that function is available inside a header file called as ctype.eh. So you are familiar with the ctype.eh. So this ctype.eh contains one of very useful, what is that? A very useful function, and let me use that function. So if is all number. So is all number will check whether it is an alphabet. So it's going to check whether the given character, whether it is an alphabet like this A, B, C, D, or whether it is a numerical value. So if it is an alphabet or a number, we are going to print it directly. We are sending it directly to the output. How do you send it to the output? You know very well. We are going to use a printf statement for output. So I'm going to write the C into the output. And because don't get confused, this is the variable C. Okay, this is for the character. For the integer, you say %d. For the floating, you write a %f. For the character, you write a %c, and that is what I have written over here. So that part is done. Let us look at the next story. Next story is if you get this open bracket, you simply push it into the stack. So that is very easiest one. If you get this open bracket, you push it into the stack. So this is a very simple story. So else if okay, if this C, that is the ordinary one character that I'm taking, if it is equal to open bracket. So if it is equal to open bracket, see in the examination, some of you will write it as C. If C is equal to C, some of you will write like this. This is not C. This is the open bracket that I have written. So this is this open bracket that I'm representing. If it is open bracket, then you push it into the stack. You don't do anything. So you just push it into the stack. So simple as that. Now let's look at the other condition. Now the obvious condition will come over here is I'm not going to write the whole story here. What if it is a closed bracket? So if you open bracket, well and good. If it is a closed bracket, what are you supposed to do it? So if it's a open bracket, you push it into the stack. If it's a closed bracket, are you going to push it into the stack? The answer is no. You're not going to push the closing bracket into the stack. Then what are you going to do? Suppose, let's say, I'm again, don't take this expression. Suppose you have a situation like this. Okay, let's say you have a situation like this. Okay, and maybe you have many things over here. So the top of the stack is here now. So your stack is full up to this point. Just assume that one situation, one fine day, your stack is having so many values, and now you are supposed to, now what you get is the closing bracket. Now the closing bracket comes into picture. Now I told you you cannot push it, push the closing bracket into the stack, nor you can send it to the output. So both of them are not allowed. So if you get the closing bracket, what are you supposed to do it? If you are getting a closing bracket, then you have to pop all the elements from the stack until you reach a opening bracket. So that is what you are supposed to do. So if you get a closing bracket, okay, pop all the elements in the stack until you get the open bracket. So until this open bracket comes, pop all the elements. So after popping them, what are you going to do? You're not going to throw them out. When I say pop the element and send it to the output. Pop the element and send it to the output. Don't just throw them away. Pop it from the stack and send them to the output. So how long you are going to do it? So you are going to repeatedly, you are going to pop this one, you're going to pop this one, you're going to pop this one until you get this, which is this closing, the opening bracket, you pop them. So you have to continuously pop the element. How can I write the continuous story? I'm going to use a looping structure. So let us start with the looping structure. So how do you write the looping structure? So I'm going to say while, so you know very well, okay. Let me take a temporary variable. I can call that temporary variable as a t, but I'm going to call it as x, because if you write temp, it is 4 letter. So I'm going to call it as x. As simple as that, it is 1 letter. So let me pop an element. So whichever element, remember, whichever element you are popping, that element has to be sent to the output. So first I'll take this one, take this element out of the stack, and I'm going to store it in x, a variable called as x. Then I'm going to use the printf statement to send it to the output. So what I'm doing is I will take one element from the stack, I will pop it. and store it in a temporary variable called as x. Then I'm going to move the use the printf statement, and then I'm going to send it to the output. So I will take one element. So I will pop one element, and I'm going to store it in the temporary variable called as x. And finally, I'm going to pop this one. Yeah, and finally, I'm going to send it to the, what is that? Our output. So I'm going to send it to the output. How do you send it to the output? So I think I don't have to type this one. I'm going to copy this one. So Control C and Control V. This is easy option. So use instead of C, you are going to the X here. So you are going to pop one element into the X, and that X you are going to send it to the printf state. So that is what I have done. So you pop one element and put it into the X and use the printf statement to send it to the output. So this is what you are doing. So you are going to pop one element into X, and then that X you are going to send it to the output. However, very important thing, you are supposed to stop when you are going to stop. So you're going to pop this one, you're going to pop this one, you're going to pop this one. But if you get this, what is this open bracket, you are not going to put it into X and send it to the output. You are not supposed to do it. So if, and as long as you are not getting this open bracket, you are supposed to send it. So the minute you get the open bracket, you stop it. So I'm going to say, as long as you are not getting the open bracket, you're going to repeat this one. So what is that you're going to repeat? You're going to pop one element into the X, and you're going to send that thing to the printout. You're going to pop one element, you're sending it to this one. As long as the element that is popped out is not equal to the open bracket. The minute you get the open bracket, it is the story is over. So I'm going to put this one into one more bracket. So I'm putting too many brackets over here. This is for brevity, I'm doing it. So this part is you are taking an element and putting into X. So you have two brackets here. Then you are checking whether this part is not equal to this part, and the whole thing is again put inside bracket, and you have a while loop. And you may say that, oh, already while loop on bracket is there, why are you putting one more thing? Because it's not over. Now sometime it may so happen that some person might not have put the closing open bracket. So it can happen right now. So somebody has forgotten to put the open bracket, but there is a closing bracket. Now what will happen? This will go, this you are going to pop out, this you are going to pop out, this something is there, you're going to pop out, and what will happen to the top? As you pop, the top of the stack will start keep on decreasing. Top will, when you pop out this element, top will move by one down. When you pop this element, the pop will move by one. So pop is will the not pop, the top is going to go down. As you pop an element, the top will decrement by 1 1 1. So the top will keep on decrementing until the top becomes equal to -1. When the top is equal to -1, you know very well the stack is empty. When the stack is empty, you are not supposed to pop anything out of the stack. So you must be careful whenever you get the closing bracket. You are supposed to pop the element until you get the open bracket. Suppose if the open bracket is not there, you must be careful enough to check whether the top has reached the -1. In other words, whether the stack is empty. If the stack is empty, don't try to pop anything out of the empty stack. So how am I going to check it? So you are going to do all this story as long as top is not equal to -1. Remember, if the top is equal to -1, what is the meaning of it? If the top is equal to -1, the stack is empty and you cannot pop out anything from an empty stack. So first condition you are going to check is as long as the stack contains an element, or in other words, if the stack is not empty, then you think of popping an element. However, the element that is popped out should not be equal to the open bracket. So how do you connect these two things? I'm going to say and here. So two conditions. What are the two conditions? First one is the stack should not be empty. And what is the second condition? The popped out element should not be equal to the opening bracket. So I'm going to reduce the brackets now, don't get confused. So this is one part. So this is one part and this is the other part. So I'm going to reduce the extra spaces that I have added here. Okay, so then, okay, so what about this bracket? This is the bracket of the while loop. So this is the while loop bracket. Okay, done. So this is done. Okay, so you are supposed to pop up the element from the stack continuously. So let me remove this space also. Now the question comes, okay, you are done with this story. What is the story? So that you have told is that if it is what is this? If it is the open bracket, you just let me put that open bracket here. If it is an open bracket, you put that into the stack. If it is an operator, you just put it into the stack. You said okay. And if it is a closing bracket, you just pop the element. Done. Now the question is, if it is an operator, can you simply push them into the stack? That story will come. Now some fine tuning has to be done. If it is an operator, so we have taken care of the opening bracket is over. We have taken care of the operands, either numerical or alphabet we have taken care. We have taken care of the closing bracket we have taken care, but there are a lot of operators are there. So you have this plus, you have star, division, and this, and you may also have a caret symbol. So what is this a caret symbol? I hope you are familiar with the caret. How do you get this caret symbol? Caret is you shift and 6 on the numerical pad, you get this one, caret symbol, the top like arrow. What is this caret symbol? So you in your Microsoft Word, you write 2 to the power 3, 2 cube. This is a superscript. But in the notepad, you can't write that thing. So how do you write it in the notepad? You say 2 to the power 3. So this caret symbol indicates it is exponent. And in your primary school, you have studied something called as a BODMAS rule. So in the BODMAS rule, you know very well, if you get a star or minus, sorry, minus the division, you perform the operation first. If you get a plus or minus, you do the operation later. So plus and minus 1 have the lower precedence or the lower priority as compared to star and division. And finally, this exponential has the highest precedence. So if you get the exponent, you perform the exponent first. For example, if you have 2 cube into 5, what is the meaning of it? So are you going to multiply 2 into 5? So 10, that you are not going to do it. So you are going to perform 2 cube first. The exponent has the highest precedence. So 2 cube is 8. Then you are going to multiply it with the 5 and you are going to say it is 40. Hope you are able to get that thing. So the exponential has the highest precedence. Then comes the star. Then comes the plus or star and division. Then comes this one. Now the question comes. Now, when you try to push the element into the stack, okay, you have to check what is there at the top of the stack. Okay, if the element which is there at the top of the stack has the higher precedence than the one that is being pushed onto the stack, then you have to first pop this element. So what do I mean by saying that? Suppose, say you have talents day. So is it not in the during talents day, you stage activities are going on. So you have a stage and people are dancing here. Okay, and you are sitting on a chair here, you are sitting. And you know very well after some time your principal will come, or your HOD will come, or your teacher will come. So teacher has the higher precedence than you. So your teacher will come, pull a chair and sit right in front of you. Can you do anything? You can't do anything. Okay. Your HOD will come and sit in front of you. Can you do anything? You can't do anything. Your teacher is sitting and your principal will come. And who has the higher precedence? Your principal. So principal will come right and sit in front of the teacher. Can the teacher do anything to the principal? No. So when you have a higher precedence, a higher priority operator standing in front or top of the lower priority, it is good. There is no problem. Just imagine that your principal is sitting here and watching your talents day. So principal is sitting and watching dancing. People are dancing here. They're yelling and dancing. And you come, pull a chair and sit right in front of the principal. What is going to happen? You know what is going to happen. So you being a person with the lower priority, in this case the plus, which has the lower priority, cannot sit on top of a higher priority. So higher priority, if it is there, you cannot push a lower priority element on top of a higher priority. So whenever you are trying to push an element into the stack, you check what is there at the top of the stack. If the top of the stack has the higher priority, then first send them out, okay, and then put it here. So generally what happens, if your principal is sitting and you pull a chair and you want to sit here, so you can't sit in front of the principal, you just tell the principal, sir, your chair is there, sir, your seat is there in the front row, sir, please go, sir, front row fan is there, sir, you sit there, sir, and the principal will, okay, I will go and sit in the front. So principal will walk out, and when the principal walks out, you know very well you got the chance, you can sit there. So first pop the higher priority element. So the higher priority element was there, you pop them out and then you push the lower priority element. Now it may so happen that your math teacher is sitting here. Okay, your math teacher is sitting here. Can your physics teacher come and sit in front of the math teacher? So that is not allowed. Okay, they can, both of them are equal. Math teacher is equal to physics teacher, but they can't. So even when you have this equal priority, it is not allowed. So only higher priority can, principal can sit in front of your math teacher, but your math teacher can't sit in front of your physics teacher, or other way around, it is not allowed. So as long as the priority is higher, then only you can allow, otherwise you are not supposed to allow. Now the story that has to be taken care is, so whenever we are pushing something into the stack, we have to check what is the priority of the element that is being pushed into the stack and what is the element which is there on the top of the stack. So you have to check the priority, and your math teacher in your primary has taught you about BODMAS rule. Okay, so we are supposed to take care of that BODMAS rule. So I'm going to go out of this main here where I have written this push and pop. I'm going to write one extra function that will check the priority of a given element. So given an operator, whether it is a plus, star, or anything, given an operator, we are supposed to check what is the priority, whether the priority is higher or lower or some. So in general, you are given a character C, anything, C could be plus, minus, whatever it is. What is the priority of that? So that is what we are going to write. So we are going to write a function and we are going to give a integer numbers for the priority. Lowest means 0, highest means it could be anything. So whenever I ask what is the priority, if the priority is 0 means it is the lowest one. If the priority is higher, if it is 1, it is greater than 0. If it is 2, it is greater than 1. You know very well. As you increase the priority number by 1, 2, 3, 4, higher priority means higher number. So simple as that. So let me write a function. I'm going to call this one as PRI, priority. As simple as that, PRI, because I don't want to write the whole thing in the examination. You will waste typing a big sentences. Don't write it, because you won't get time to write that thing. And I know that you are going to use your 2 fingers. So God has given you 10 fingers, but the out of that 10 fingers, 8 fingers you are given it for someone else. So you are always comfortable with your 2 fingers. That is why I am typing small things here. So I am not writing the whole thing here, so that you can type and complete the program during the examination. So I will use the word PRI to say that it is the priority. So we start checking the priority. So see, but the one thing that I told you is whenever you get the open bracket, you just push that open bracket into the stack. That means the open bracket has the least priority. Nobody cares about that open bracket. So sad about it. So if C happens to be the open bracket, don't get confused. Again, I know that at least one among you will do this mistake during the examination. They will write C is equal to C. This is open bracket. It is not C. Okay. What is the priority? Priority is 0. Open bracket has the least priority. Else, okay, I'm not going to write this one. Control C and Control V. Okay, I'm going to do that thing. Else, if it is, what is the next? BODMAS rule. Next priority is which is when plus or minus. Both of them has the same priority. Let me just pull this one. Okay, plus or minus. So if it is plus or if it is minus, your BODMAS, your math teacher has taught you. So if it is plus or minus, it is the next priority. Priority number 1. What about the next priority? I'm going to use Control C and Control V. Please kindly use this one during the examination, because you know very well your typing speed is terribly fast. So better you start copy pasting it, so it is easier during the examination. So if it is star or if it is division, so your BODMAS rule, if it is star, it must have higher precedence. If it is plus, it must have the slightly lower precedence. If it is open bracket, it is the least precedence. So I'm going to do that thing. The next one I'm going to do is Control C and Control V. Else if, let me write like this, else if it is the caret symbol, shift and 6, if it is a caret symbol, only one I'm going to say, the priority is 3. Do you have other operators? Yes, you may have 101 other operators. We are not going to take care of them. Okay, we will stick on with this one. If you have a lot of time, you take all the operators which are there in mathematics. If you don't know, ask your math teacher. They will tell you that many other operators are there, arithmetic operators are there, and you can use it. So in my case, how do you quickly format it? Right click and you get an option to say format use a style. So use this one, right click anywhere and then say this. It will format it beautifully and give it to you. So if it is an open bracket, it has the lowest priority. If it is plus or minus, you have one more priority. If it is a star, and that is multiplication and division, you have a slightly higher priority. If it is a caret, that is exponential, it has the highest priority. So you have that. Now let us come back to the main story. So we are there in the main story. So in the main story, you said that if it is an open bracket, you just push it. If it is a closing bracket, you pop all the elements. So done. Now let us continue with the other part. Else, if it is an operator, so let me just do this one. Else, so it is not the open bracket. It is not the closing bracket. It is not the operator. Now it is the operator. So before you push the operator, check the priority. So let us check the priority. How do you check the priority? So while we have to check the priority, remember, you may suppose if you are you have a situation like this, your teacher is sitting and your principal is also sitting in front of your teacher, and you want to sit there. You being a lowest priority, you want to sit. First, you tell the principal, sir, principal, sir, see, there is a fan there, sir, you sit there in front row, sir. Principal will go, okay, 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 go. I will go. Then what you can you sit in front of your teacher? No, you go to your teacher and say that, sir, maths this, sir, or physics or what, sir, please, or teacher, madam, please go and sit there, sir. In front row is for teachers. You please sit there. Don't come behind. We want to dance here. So the teacher will also go. So this higher priority, if you have more than one, pop all of them. So if you have more than one higher priority element, pop all of them until the top element has a priority less than your your priority. So that's simple as that. So you pop all the element as long as your priority is higher than the top of the element. So how do I say that? So I'm going to say priority PRI. So what is this PRI? I used this PRI, which will give me the priority 0, 1, 2, 3, and so on. So if the priority of the element which is there at the top of the stack, okay, element the top of the stack, okay, this is the priority. If where is this one? If it is greater than or equal to priority priority of the element that is being inserted. Now what is this? See, right at the beginning I told you, you extract one element from the expression and then you call it as C. Okay, so if the priority of the element which is there at the top of the stack is higher than the element that is being pushed into the stack, you have to pop them. Okay, you have to pop them. Okay, after popping them, what you are going to do? Remember, I told you, pop them. Don't just send them out of the hall. Send them to the front of the hall. So send them into the output. Don't just pop them out of the hall. Don't ask the principal to get out of the hall. You tell them you go and sit in front. Okay, so simple as that. So here I'm going to use the printf statement. So I'm going to pop this one. And after popping this, what you are going to do? After popping, where is this go? After popping this, you send them to the output. So I will write it in one line itself. So you pop them and send it to the output. So in the previous case, I have not done this. You don't try. I will give it to you, leave it to you. Why I have not done it here? Okay, why I directly didn't write a pop here? So I leave it to you. Just think what happens, or you just put this there, pop here instead of x, and you will realize that, oh, why I have not done that. Okay. So here, what you are doing is if the priority of the element which is there at the top of the stack is higher than the element being inserted, then pop them. And how long you are supposed to pop them? Send your principal to the output. So send them to the output. Send your teacher to the output. Then you go and occupy the seat. That means then you push this element. So how do you say, how do you put something into the stack is you push the element. So you keep on doing this. You keep on repeating this while loop continuously until this condition is not met. That means until all of them, all your teacher, class teacher, HOD, all of them are gone, then you are safe here, put them here. So after that, remember this is not part of the while loop. After that, you push this into the stack. Okay. So you send them all in this while loop, will send them all out, then you push them. Now there is one important thing, and what is that important thing? Whenever you pop an element out of the stack, you check whether the stack is empty. If the stack is empty, you cannot pop this one. This is a golden rule that you are supposed to follow. whenever you are popping an element into the stack. So I'm going to copy it from here. This is the golden rule that you cannot ignore. Okay, so as long as the stack is not empty, you do this story. Now if you want, this is not really required. For brevity, I'm going to put this one inside one more bracket. Now there may be too many brackets, so what I've done is this is one set, then you have and this is the other set, and finally you have this while loop. Okay, so for brevity I've done it, not really required, but unnecessary, why get confused. Okay, this is what you're supposed to do it. Now there is a general problem will come. Now let us look at I'm going to work out this program before I run this one. So this while loop that you have written here, this while loop, the big while loop that you have written, this while loop will continue as long as this you are not reached the end of the string. So let me quickly go through this part and see what is going to happen. So you know very well, you start from I is equal to 0. Okay, you take this and you push it into the stack. So this is pushed. Then 4 is there. You put that 4 into the output. 4 is there. Then you push this plus into the stack. You know very well the open bracket has the least priority. So you push this one into the stack. The top is moving here now. The top is here. And then you have 5. You put that into the output. Then you have star here. So when you get this star here, star has a higher precedence than your plus. So your principal can always or your class teacher can always sit in front of you. There is no problem. Then you have this 7. You put that into the output. It is done. Then you have this. When you try to push this element, there is already star and division. Both of them have the same priority. So you push you pop this star from the stack. So you pop them and you put them into the output and you push it into the stack. Done. Okay. Then you have the the sorry, the 2 here. So this 2, you put that 2 onto the output. Then you have this closing bracket. So whenever you have this closing bracket, you know very well that you have to pop all the element until you get the opening bracket. So you put this slash. So this is gone. Then you pop plus. This is gone. And you remove this element, open bracket, because the closing bracket, the matching closing bracket is obtained. Now the stack is completely empty. Okay, so what you have in the stack now is what you have in the output is 4, 7, 2, star, and so on. You are here. Okay, the plus. Now the plus, the stack is completely empty. Let me remove this one. Stack is completely empty. You push the plus here now. Next element plus, you push it. Okay, the 5 will come. You pull that 5 here into the output. Okay, what is the next element that you're going to get? The next element is the null. So that means your expression is over. But did you get everything in the output? So what you have in the output is you have 4, 5, 7, star, 2, slash, plus. Sorry. You have this up to here. Okay, you have up to that point. Slash is there. Okay, you have this up to here. Don't worry about this one. Don't leave that thing. Okay. Now 5 is there. You put this 5. Your stack is empty now, but this plus is still there here. This plus, which was here, this plus is still there in this stack. So what do I mean to say is I want you to pay attention to this particular point. That is, even though you have passed all the elements of the given expression, even though you have reached the null, that is the end of the string here, there may be some operators which are still lying on your stack. Okay, you may have some element. In this case, this plus was still there in this stack. Okay, now when you have this one, you have to suppose you have reached the end of the string, and if you find that there are some elements which are not being popped out, so there is some things which are still there in the stack. The stack is not empty. In other words, in that case, so if you find that the stack is not empty, simply push them out or pop them out of the stack and put them into the output. So if after reaching the end of the string, okay, in other words, after reaching the end of the string, how do you get the end of the string? That is when you reach the null. If you find that there is some elements which are still there in the stack, if you find that something is there in the stack, just pop them one after the other to the output until you reach the end of the stack. So if any residual, we say that if there are any residual operators are there in the stack, then just pop out. So that is the last thing that you're going to do. If it is there, if it is not there, well and good. If nothing is left over, so when you reach the end of the expression here, if the stack is also empty, well and good. If the stack is not empty, something is there in the stack, some elements are still there in the, some operators are still there in the stack, then just pop them one after the other. So the last thing that we are going to do is, after this while loop, remember, after you have reached the end of this expression. So after you have reached the end of the expression, after you reach the end of the expression, if there is something in there in the stack, just empty the stack. So simple as that. So let's write, this is after this while loop. Remember, this is after the while loop. So if after the while loop, if something is there, you just pop them out. So I'm going to just use the while loop. So I'm going to say while top is not equal to -1. So while top is not equal to minus, did I put a double equal to, okay, top is not equal to -1. Okay, you just pop the element and push them. So I'm going to use Control C here and Control V here to copy paste it, so that I can reduce typing. You pop all the elements of the stack. So let me keep my finger crossed and I'm going to execute it. There may be some errors, syntax error or logical errors. So if it is there, we will fix it. So let's don't worry about it. Let me run it and see whether I'm getting it. So I got the first error here. And what is the first error? Am I getting it here? Okay, sorry. So I've not put this C here. So I'm checking for alphanumeric. But alphanumeric of what? It is saying, okay, so you are checking for what? So alphanumerical of this one character. So whenever you get one character from here, okay, you have to check that character. So I said simply alpha numeric. It is asking you what is this alphanumeric that you're talking. So let's run it. Hopefully the things are proper. I'm going to copy it from here. I don't want you to see me typing the thing. So I'm going to just copy it here and I'm going to press enter. And this is what you're going to get it. So let me, I have done this homework and my homework says something else. And I think this itself has an error. So this should have been +5 plus should have been there. One plus is missing here. Let me just check. Let me try it with the one other. Let me try see whether I'm getting. Otherwise, I'm going to just check. There could be some logical error. See, when I start talking and I'm doing it, I sometimes tend to make some mistakes. So let me see whether I am getting everything. I think I am not getting the last one, which is not getting popped out. So let me just cross verify what is the mistake. I'm supposed to get this. See, up to here it is coming. The last one is not getting popped out. Let's see what is the error. So let me just check what is that I am not getting. Oh, sorry. So I got it. See, I am checking for equal to, sorry, it is a not equal to. Extremely sorry about that. This is not equal to. See, the equal to means that the stack is already empty. See, if you see this story is, I told you as I talk and do it, sometimes I just tend to make mistakes. Okay, if it is equal to means you are already there here. No? Then what is else is there? So If it is not equal, sorry, this story about that, this story, this is not equal to, make a note of it, this is not equal to, it is not equal to, it is not equal to, as long as top is not equal to -1, you just pop it. Okay, so simple as that. Sorry, just run it and let's see whether I get the same answer. Control C and Control V. And some of you don't know this story, so how do you paste it here from this one if you have it from here? So if you want to paste it, just right click here and just right click, you get the output there. Okay, so done. So I think now it is matching. So you see, I hope this is matching now. So 457 star. I have done my homework there. Okay, don't worry, don't say that that is wrong. Did my homework, and I'm showing you what is coming over here. So let me run again with this one. For this also I have done my homework, and this is the infix expression, this is the postfix expression. I've written the postfix expression next to it. So I'm going to just type it and I'm going to just show you that it is matching. This is what I have worked out: 36 plus 24 star minus 7 into that. This is with the numeric. So what if you have alphabets instead of numbers? 3 plus 5 plus what if you get the alphabets? Will it work? So let me run it and see whether I'm going to get this one. So let's say this is my output, and let me just keep it here. So this is the one that I have worked out, and this is the one you are getting it without last time I used these numbers 3, 6 and so on. Now I'm using variables, that is x, b, a, b and so on. So a, b star c, d to the power e. So I'm also using this power E, F, D star. Okay, last one, slightly longer one. Control C to copy it, and let me run it and just right click here and you get it. So let's see what you are going to get. So let me slightly bring it down and let's see whether am I getting the answer. So if you look at it here, A, B, C, D to the power E minus F, G star F, G plus star. Okay, I'm getting it. Okay, so this is it. That's all in this exercise. Thank you for your interest. We will meet again in the other exercise. Thank you.